Welcome back. We are going to continue with our simplifying problems. Problem 0.3. And I'd like us to look at problem 42, which says write the expressions in terms of positive exponents only and avoid all radicals in your final form, right? So we are given a couple of expressions to write them in terms of positive exponents and remove all radicals in our final answer. So number 42, right? We are still in problem 0.3. Number 42 says the fifth root of x squared y cubed z to the minus 10. X squared y cubed z to the minus 10. We want to write this expression in terms of positive exponents and remove all radicals. Okay, so the first thing is to write all negative exponents and as positive exponents. Then the next thing, we remove the radical sign. Okay, so the only negative exponent we have there is this one, z to the minus 10, right? And note that we will mostly be using the following two laws. So the law of radical, which is the change from radicals to exponents, which says that the nth root of x is x to the 1 over n. This is what we will be using to remove all radicals. And we will be using this other law to write our exponents, negative exponents, as positive exponents, basically these two laws. All right, so this becomes x squared y cubed divided by z to the 10, right? So our z kind of comes to the denominator following this law there, and its exponent becomes positive. Okay, then to write this without radicals, it then becomes x squared y cubed over z to the 10 all to the power 1 over 5 by this other law there, all right, of radicals. So we can also simplify further by distributing our exponents, the exponent 1 over 5 there, to each of the expressions in the bracket. It then becomes x to the 2 over 5, y to the 3 over 5, divided by z to the 10 over 5. Okay, which is x to the 2 over 5, y to the 3 over 5, divided by z squared. And this is then our final answer with all positive exponents and no all positive exponents and no radicals. Okay, let's take the next example. Next example I would like us to take is number 48. Okay, 48 of the same 0.3. It says given x to the 2y to the minus 2 all to the power minus 2, right? And we want to write these guys as positive exponents. Don't have any radicals here, so all we need to do is just to write our negative exponents as positives. But I would like us to start by first distributing this exponent to each expression in the bracket using one of our laws, the distributive law. So it becomes x to the 2 times minus 2, y to the minus 2 times minus 2, which is then x to the minus 4, y to the 2, right? So that we see that the only negative exponent we have is the x to the minus 4, which we can write as y squared over x to the 4. Okay, and that's our expression without any negative exponents. Okay, and then the last example for this type of question is number 49, which says that given square root of x minus square root of y Okay, so we don't have any negative exponents here. All we need to do is just to remove our radicals using the change from radical to exponent law. All right, and this would then just become x to the power half minus y to the power half. Okay, and that's then the final answer. And that's the final answer there. Okay, now let's move over to rewrite the exponential forms as radicals. Given exponential forms of expressions, write them as their corresponding radical forms. So the first one that's given to us there is number 53. Okay, question 53, which says A plus B minus C all to the power 2/3. Okay, and directly using our law, which says that the nth root of x is x to the 1/n, all right? We can just move from this side to this side. Okay, that's how we are moving from the left-hand side, the right-hand side to the left-hand side, and see that this is then a plus b minus c cube root, right? All of this squared, and this is then the radical form of this. Okay, so remember that the generalization of this law is the nth root of x to the m is nth root of x all to the m, which is x to the m/n. Basically, that's what I have used to achieve this. Okay, that's what I've used to achieve this answer. That law there. So that's the law that's used to change radicals to exponents and vice versa. So if we look at number 57, 57 says 3w to the negative 3/5 minus 3w all to the power negative 3/5. And we want to write this as a radical. So we do that term by term. We see that there are two terms in this expression. So the first term, the exponent is only on the w, while in the next term, the exponent is both on the 3 and the w. Take note of this difference. Take note of this difference. So I would like to start by writing my exponents. Remember that with radicals, n is always greater than 1, all right? N is always a whole number, a positive number, okay? N must be some positive number. N must be some positive number there. Okay, so that's that. So therefore, with my n's here negative, I need to first of all write them as positive exponents before I can then write my exponential form into its corresponding radical form. So this becomes 3w 3/w to the 3/5 minus 1/3w all to the 3/5. All right, that's what it becomes. Let me just take out these. Okay, then we are ready to then write our exponent as a radical. We're then ready to write our exponent as a radical. So the whole thing becomes, the first one becomes 3/5 root of w cubed minus, the second one becomes 1/5 root of 3w cubed, like that. And that's then my radical form for that expression. Okay, so the last thing we are going to look at here is rationalizing denominators. Rationalizing denominators. Rationalizing denominators. Rationalizing denominators. The last thing we are going to look at in section 0.3. So rationalizing the denominator of a given fraction whose denominator is a radical simply means write this fraction as an equivalent fraction without radicals in its denominator. Okay, for instance, if I'm given the fraction 1 over square root of 2, for instance, okay, rationalizing this simply means rewrite this as an equivalent fraction without radicals in the denominator. Okay, that's what rationalizing simply means. We write fractions as equivalent fractions without radicals in their denominator. So equivalent simply means you will not be changing the numerical value of the fraction, all right? It's only the structure that may change because of no radicals in the denominator, but the numerical value should remain the same. You shouldn't change the question. Okay, so in order to rationalize denominators, the first step towards rationalizing denominators is to change all radicals in the source table 1. Steps to rationalizing denominators. The first step is to change all radicals in the denominator to exponents, okay, to their corresponding exponents. Change all radicals in the denominator to their corresponding exponents first, okay. The step 2 is then to determine, okay, determine what you need, determine what is needed determine what you need, okay, to combine to the fraction or the radical, sorry, determine what you need to combine to the radical in the denominator, to the radical in the denominator to change it to the nearest whole number, to the nearest whole number, to change its power, not its power, to change its power to the nearest whole number, to change its power to the nearest whole number. And the third step is then to combine and eliminate. Combine and eliminate all radicals in the denominator. Combine and eliminate all radicals in the denominator. Okay, so these are the 3 steps that you need to carry out rationalizing. Let's look at a couple of examples here. So the first example says I'm looking at number 62. I would like to start with number 60. All right. I am rationalizing denominators now, starting with number 60. Okay, number 60 says, given the fraction 3 over 4th root of 8, rationalize the denominator of this fraction. So rewrite this fraction as an equivalent fraction, but without radicals in the denominator. So how do I do this? Step 1 is to, first of all, write all radicals in the denominator as their corresponding exponents. So this becomes 3 over 8 to the 1 over 4. All right. So what I want to do is to make this power 1 and not 4, because when this power becomes 1, this expression will no longer be a radical. All right. Because the purpose is to eliminate all radicals in the denominator without changing the numerical value of the expression. That's rationalizing, basically. So I want to make this power here 1 and not 1 over 4. So I ask myself, what can I add to 1 over 4 to give me 1? So I can add, what can I add to 1 over 4? So x plus 1 over 4 should give me 1. What is x? Right? It's quite easy to solve this linear equation for x. And I will see that x will be 1 minus 1 over 4. So simple, just take 1 minus this power to get the other part that you need. So it's going to be 3 over 4. Okay, so I need 3 over 4 to add to this 1 over 4 to make the power of 8 1, so that my denominator will no longer be a radical. Okay, so how do I bring in my 3 over 4 without changing the expression there in the denominator? Remember, my intention is not to change the expression. It's just to write it as an equivalent expression. So the only way I can do that is to multiply numerator and denominator by what I need. 8 to the power 3 over 4 divided by 8 to the power 3 over 4. All right. By doing this, so it's 8 to the power 3 over 4 divided by itself is 1. So it's like multiplying this expression by 1. So it leaves it unchanged, basically. All right. This is just an algebraic manipulation, as we call it. Okay. Just to do what you need to do to get what you want to get. So 8 over to the 3 over 4 divided by 8 to the 3 over 4 is 1, basically. So multiplying this expression by this one is like multiplying this expression by 1, which leaves it unchanged. Okay, so once I have done this, the next thing now is to then use my law 1 of exponents. When you are multiplying, so this basically is then 3 times 8 to the power 3 over 4 divided by 8 to the 1 over 4 times 8 to the 3 over 4, basically. All right. And we know that by our laws of exponent 1, when you are multiplying expressions with the same base, you can simplify by adding their powers. So if we apply that law to the denominator there, numerator becomes 3 times 8 to the 3 over 4 divided by 8, basically 8 to the 1, which is 8. Okay, so all radicals have then been eliminated from the denominator, and denominator has been rationalized for this fraction. Okay, so mind you, the numerical value of this and this are actually the same. It's just their structures that look different. So we haven't changed anything yet. All right, we have not changed the fraction, we have only rationalized its denominator. So basically, this is a detailed explanation of rationalizing denominators. Okay, let's take a few more examples for clarity. Let's take more examples to make this clear. So I'm looking at number 62. 62 says rationalize y divided by square root of 2y. Okay, so first step, write all radicals in the denominator in their exponential forms. So this becomes 2 to the 1 over 2, y to the 1 over 2, all right? Or 2y all to the power 1 over 2. It's the same thing, basically. So I ask myself, what do I need to add to these powers to make it 1? Okay, because if this power becomes 1, this expression will no longer be a radical, but a non-radical, a whole number, all right? Which is what I want, because rationalizing simply means remove all radicals from the denominator without changing the fraction. Okay, so I need to add a half there to make it 1 and a half there to make it 1. So it simply tells me I need to multiply this thing by 2 to the half, y to the half, over 2 to the half, y to the half. All right. Again, this divided by this is 1. So it looks like I haven't changed anything. Okay, this is very important. Okay, so the whole thing then becomes multiplying denominators now. 2 to the half times 2 to the half. Okay, I'm applying law 1 to same basis. Expressions with the same basis, I'm applying my law 1 to them. So I apply law 1 to this expression and this one. I also apply it to this expression and this one. Same basis, we add their powers. So the whole expression becomes y times 2 to the half y to the half divided by 2 to the half times 2 to the half becomes 2 to the half plus half by my law 1, y to the half plus half also. Okay, so the whole thing becomes y times y to the half, 2 to the half over 2y. Notice that I am not so concerned about simplifying the numerator because that's not my target. My target is rationalizing the denominator. So I don't really care what the numerator looks like. You can simplify if you choose to, or you can leave it like that. All right. What I want to see is the denominator rationalized. So again, all surds or all radicals have been removed from the denominator, and this denominator has therefore been rationalized. Okay, let's take another example. So another example will be number 64. 64 says given 2 over 3 times cube root of y squared. Okay, 3 times cube root of y squared. Rationalize this denominator. So first step again, write your radicals in the denominator as exponents. Becomes 2 over 3 y to the power 2 over 3. Okay, so notice that 3 in the denominator is not a radical. So we have no business trying to rationalize it. All right. This is the only radical we have in the denominator that we want to rationalize. Okay, so be careful with this. Common mistake will be to multiply by 3 to some power, y to some power. Okay, 3 is already a whole number. It's not a radical. So what do I need to add to 2 over 3 to make it 1? Okay, so simple. 1 minus 2 over 3 gives me 1 over 3. Okay, so 1 over 3 plus 2 over 3 is 1. So I need y to the 1 over 3 to add to get my answer. Okay, so basically then I multiply numerator and denominator by y to the 1 over 3 over y to the 1 over 3. Again, these guys divide each other to 1. So it looks like we haven't changed anything. Actually, we haven't changed anything, not it looks like. All right. So from there, I can then apply my law 1 to the same basis in the denominator. So the whole thing becomes 2y to the 1/3 divided by 3y to the 2/3 plus 1/3, which is 2y to the 1/3 over 3y. Okay, denominator rationalized, basically. Okay, let's take a few more examples on this. This is very important. Okay, it's a very predominant question in most of your assessments. So I would like to get the understanding of it very right. So if you look at number 67 on rationalizing denominators, if we look at 67 there, it says 5th root of 2 divided by 4th root of a squared b. Rationalize the denominator of this fraction. So in order to do this, first step is to write our radicals in the denominator as exponents. Okay, notice that we don't care about the radicals in the numerator. We are only rationalizing the denominator. Okay, so denominator is written the same way, and we write these guys as let me just remove this line, make it easy. We write these guys then as a to the 2/4, b to the 2/4, b to the 1/4. Okay, notice that this 2 is only on the a alone. Okay, take note of this. So this is in its exponential form. Once it's in this form, I can simplify further. I see that 2/4 simplifies to 1/2. All right, or I can still leave it this way. I'll write it as 5th root of 2 divided by a to the 1/2, b to the 1/4. Okay, because 2/4, 2 divided by 4 is basically 1/2. Okay, so that said, I ask myself, what do I need to add to a half to make it 1? I need a half, all right? So I'll be multiplying top and bottom by a to the half over a to the half, so that I change nothing. What do I need to add to 1/4 to make it 1? I need 3/4. So it's simple, 1 minus 1/4. You get 3/4. All right, so therefore I'll also be multiplying by b to the 3/4 times b to the 3/4, basically. Okay, whatever you do in the numerator, you do the same on the denominator so that you leave your fraction unchanged. Realize that these guys cancel each other to 1. Okay, so once we have this, the next thing we can do now is just to apply our law 1 to same basis. All right, so this base and this base are the same. Okay, this is not equal to, we are actually multiplying here. Okay, this is times. Okay. So if I apply my law 1 to same basis, because this whole fraction becomes 5th root of 2, a to the half, b to the 3/4 divided by a to the half, b to the 1/4 times a to the half, b to the 3/4, basically, right? This expression, which is this, times this expression, which is times this. Okay, so by law 1, the whole thing is 5th root of 2 a to the half b to the 3 over 4 divided by a to the half times a to the half. We can add up their powers by law 1, all right, to just get a to the 1, which is a, and then b to the 1 over 4 times b to the 3 over 4 by law 1. We can add up these powers to get 1 as well, which is b. And our denominator has been rationalized, basically. Right. So that is rationalizing denominators in a nutshell. I think I should take one more example, then we will be fine with rationalizing denominators. Look at number 80. So number 80, this is rationalize the denominator of 3 over. Let's just take another page. Number 80. We are rationalizing the denominator of 3 divided by cube root y fourth root of x. Okay, and we want to rationalize the denominator of that. So first things first, write all radicals in the denominator in exponential form. So it becomes 3 divided by y to the 1 over 3, x to the 1 over 4. Next, I find out what I need to add to these powers to make them 1. All right. So what do I need to add to 1/3? Simply take 1 minus 1/3 and you get what you need, which will be 2 over 3. Okay, so therefore I multiply top and bottom by y to the 2 over 3, y to the 2 over 3 times, what do I need to add to 1 over 4 to get 1? Simply take 1 minus 1 over 4, which will be 3 over 4. Okay, so x to the 3 over 4, x to the 3 over 4. Okay, so the whole thing then becomes, oh, this is not equality, this is multiplication. Why do I keep making this error? So the whole thing becomes 3y to the 3, 2 over 3, x to the 3 over 4 divided by y to the 1 over 3, x to the 1 over 4 times y to the 2 over 3, x to the 3 over 4. Okay, which is, so applying my law 1 of exponents, you are multiplying expressions with the same base, you add up their powers. So for the y's, if I add up their powers, I get 2 over 3, x to the 3 over 4 divided by yx. Okay, the addition of the powers will always give you 1 if you get these fractions right. And our denominator has therefore then been rationalized. So that is that about chapter 0.3. This is all you basically need to know in 0.3. Thank you.